I'll start with the next set of programs, that is write a program to add two 8-bit numbers. Here, how do we write a comment? Start with a semicolon. Okay. So here we have to write a program to add two 8-bit numbers. Now, can you put it in the chat box? Which is the instruction that is used to add two 8-bit numbers? Which is the instruction you need to follow with the syntax? Okay. In the chat box, you put to add two 8-bit number. Just the instruction I need. ADDC. Any other add instruction? ADDR, ADDM. Very good. R represents register, M represents the memory location. So you have here, consider ADD, ADDR, or you can go with ADDM, or you can go with only two instructions. ADI, 8-bit number. Syntax is very important. 8-bit data. Next, ACI, 8-bit, 8-bit data. Next, ADCR, ADCM. So these are the different instructions. DAD instructions is used to add two 16-bit numbers. So as per the program says, we have to write a program to add two 8-bit numbers. Okay, so for that instruction, you can use any one of the following add instructions. Okay, in 1, 2, 3, 4, 5, 6. You can use any one of the 6 to perform. But here in this particular example, I am using an add instruction with register R. So which is the register you want to take? For example, I take register C. So what happens with this particular register? What does it say? It says the content of the accumulator is added with the content of C register. But by default, what is the content of A register? Here it is 0. What is the content of C register? It is 0. So it will just add the content of A, that is 0 plus 0. You have not stored any value in A register and in C register. So how will you store the values in either A register or C register? What is the instruction that you will make use of? You can use the instruction called as MVI instruction. Very good, Aisha. So here, whenever you want to store any value into a register, you can use MVI instruction. What is the syntax for MVI? You have source and destination. Which is the source? Which is the destination? Does first come source, then destination, or first comes destination, then the source? So first comes the destination, then comes the source. So destination can be a register, since you have to first store in the accumulator given 8-bit number. Okay, so what can be that 8-bit number? Consider I am taking 26H. Okay, 26H is an 8-bit number. The second number where we have to store is MVI. Consider C register I have taken. So C comma 45H. I've taken two values. You can take any two values that you want to consider. So you have given the input in A register and C register. Okay, you are adding the contents of C register with A register. Okay, finally you have to give halt. This is the just a simple program to find or to add two 8-bit numbers. So here when you are executing the program, always remember load me at 00. Okay, and memory you have to start with 00. I've already told you here it will be decimal numbers, whereas this address is in hexadecimal number. Here all will be stored in the hexadecimal numbers. So we will execute this particular program step by step. Okay, start. First I need to save it. So MVI, if you can see here, see the values are changed. Okay, I told you as per the instruction, either it will take one location, two location or three locations. So for MVI instruction, it takes 62 and location 0000 and location 0001H. Again for MVIC, it takes 0002 and 0003. And for add C, since it is followed by an letter, it will take only one location, that is 0004. And finally for halt, again only one location, 0005. I've already told how it needs to be done. So here you have 26H, that means 26 is an hexadecimal number, and where it will be stored, it will be stored in the accumulator. So here when you give, can you see here? A you have 26. Next C you'll have 45H. So you can store the content 45 into the C register. Next you have add C. What does it say? Add the content of A register with the C register. So you should add 26 plus 45. What is 26 plus 45? Can anybody give me the answer? Okay, fine. I'll only tell it. So it will be 6b. So that 6bh will be stored here. So what will be before execution? Before execution will be the content in A and C, which is 26h and 45h. And finally, after performing the add instruction, you have the value added and stored in 6b. Okay, and here if you can see, initially 62 is the decimal value for MVIA, whereas 38 is the decimal value of 26. So if you see here 26, two decimal means you have 38. So that is the value it is stored here. And 14 is the decimal value corresponding code for MVI C. Okay, MVIE the code is different. MVIC the code is different. This 69 is whatever you write here 45 to decimal, if you convert 69, that is what you can see here. And for add C, the code is 129 in decimal value. You have to convert it to hexadecimal and write. Finally halt, the code is 118. So this is a program to add two 8-bit numbers. Next we will see write a program to add two 16-bit numbers. File, new, and here whenever you are doing reset all, okay, so that it changes to 0. So you have to add two 16-bit number. I told you a simple instruction to add two 16-bit numbers is just a DAD instructions. So the syntax for DAD instruction will be DAD with register pair. So we have to decide here what is the register pair. So by default what happens? It will take HL equal to HL plus whatever is the register pair involved. For example, consider I will take the register pair as D. When I say D, which are the two registers that will be involved here? Which are the register pair? When I say with D, DE. Very good. Okay. So whenever I say DE, so here instead of HL, it will be DE. Okay. So it will add the contents of HL plus contents of DE, and where will be the result stored? It will be stored in HL. Now by default, initially what is the value of HL? H and L, here you can see 0 and 0, whereas DE again it is 0 and 0. So you have to initially store the 16-bit data into HL and DE. So can you all tell what is the instruction to store a 16-bit data into the register pair? LXI instruction. MVI instruction is used to store only 8-bit data, but if you have to store 16-bit data, you have to use LXI. Okay, so we will see with LXI instruction. We need how many LXI instruction? 2 LXI instruction. So the syntax for LXI instruction is LXI register pair with a 16-bit data. That is what needs to be given here. Again, here also we have LXI register pair with a 16-bit data. Okay, so here what will be the register pair? Initially I'm taking HL. So instead of register pair, I just put it as HL, and here instead of the 16-bit data, I give the actual number. Consider 2453H. This is a number, random number. 16-bit always consists 4 digit. 8-bit it is 2 digits. That you have to keep in mind. Next, for DE, give it as DE and give a random 16-bit number 1367H. Okay, this is just example, and finally there is some change needs to be done, but finally I will show you with halt. Okay, this is not the complete program. There will be some change. Instead of giving DE, I should give D. Instead of giving HL, I have to give H. Okay, that is a mistake I have done. See the color change. When I had given HL, it was in black, which says that there is an error there. It is not the right instructions which you are giving. So when I give H, it changes the color to green. This says your program is right. You save this program. Okay, save it as add16bit .asm. So that since it is an assembler language, so you have to save it as .asm, which I have already explained. Okay, so you have to execute here one by one. So if I give, before executing, remember you have to give reset all, so that all the values are changed to 0. This is step-by-step code. If you want to execute completely, you can do this, but you should understand what is the input, what should be the value before execution, what should be the value after execution. Here I have stored 16 bits, so this 24 will be stored in H, 53H will be stored in L. Okay, 13 will be stored in D, and 67 will be stored in E. So when you execute, I'll just execute. Okay, here you have different values. This I'll come to this memory later. So now what happens in this case is in HL, where is HL? Here. What will be the value stored? So if I execute, can you see 24 and 53? So that is stored in this particular HL register, 24 and 53. Whereas in D register, what will be stored? In D, 13H, and in E, it will be 67H. So if you execute, it will be this way. So what happens when the addition takes place? Okay, so here it will be 7 plus 3, which is 10, but in hexadecimal, instead of 10, you have to give it as A. So instead of 3 here, the value will change to A. Okay, 6 plus 5, it is 11, but you are not saying 11 with 1 carry. Here Hexadecimal value is from 0 to 15. So up to 15 it takes the value. So 11 means it will be considered as B. So it will be here BA. That is the L value. Next come here, 3 plus 4 is 7. 2 plus 1 is 3. So it will be 37 here. If I execute, can you see here? It is 37BAH. Now it comes to an halt saying that end of the program. But I don't want this to happen just like that. What I want to do the change is this HL value, whatever is there in HL, I want to store it in the respective memory location. I don't want it to be permanently in HL register. Rather, I want to store the content of HL into a memory location. What is the instruction you all can give for it? LHLD, SHLD, STA, give LDA, then understand one thing, STA and LDA can store and load only the accumulator content. You cannot load and store HL register. Now here Shweta has told LHLD, Aisha has told SHLD. So in LHLD, what does L stand for? L stands for loading into the HL register from the memory location. But SHLD states storing the content of HL register into the memory location. So what is the instruction I need? I am saying I want to store the content of HL into the memory location. So my instruction will be used here is SHLD. What is the syntax for SHLD? You have to give a 16-bit address. Okay, SHLD says you have to give a 16-bit address. So automatically whatever is there in HL will go to that particular location. Now how will I get memory location? Can you see here this towards the right? There are lot of memory locations up to 03EH. Sorry, E7. So I have to give any one of these memory locations rather than giving towards the end. Consider I will give this one 0010H. So I will give here saying that 0010, sorry, 0010H. Now what does this instruction say? What does SHLD say? How many values are there? There are two values. One is H value, one is L value. But I have given only one memory location. And in each memory location, it stores only 8-bit data. That is, either it will store L or H. But I want to store both H and L. So SHLD instruction, what does it say? It says that, okay, it says that the L content, that is BA, will be stored in location 0010H, and the next content, that is H content, will be stored in the next memory location. So we will execute it once again and see. Okay, reset it, give reset, all the values are 0. Again start executing. Now you see the values are changed. It has come up to 0008. Previously it was only till 0008. Okay, so LXI, you all know that instruction stores. D, it stores. DAD, you know, it will add and store automatically in HL. Now we have to see with SHLD. So if you see here, which location we have given? Location 0010 and 0011. So when I execute, okay, in 0010 I got 186, but here I have got it as BA. So why is it? Because these values will have only decimal values. So check what is the value of BA to decimal. It is 186. That is what is given here. Whereas next is 37. What is the decimal value for 37? We check. It is 55, which is got in the next memory location.